If we're ready. All right.
Okay, I'll start it. Thank you everybody for coming. Today, this is our Freight Frenzy Quarantine Workshop, season 2. Today we'll be our topic today is building robots with Robo Sapiens team 14503. Ooh, that was fast.
Sorry.
This team will be the ones actually presenting today. This is our first team actually being a presenter instead of us Vistas or Sanjak being the ones to present today. I'm your host, Reed Thornton, First Vista, and I will pass it off to Robo Sapiens.
All right. Hi. So we are the Robo Sapiens, team 14503. This is our, I believe, 4th year participating in FTC. And we're going to give you a little overview about how to build robots. So my name is Kaveen, and we're going to get started.
Hello, my name is Vidur, and firstly, I'm going to be talking about the Rev Expansion Hub. So the Rev Expansion Hub is basically, you can compare it to the CPU of your computer. It's one of the most important parts of your robot, and it basically controls all the mechanisms on your robot. So it has multiple ports, as you can see on the image, where you can connect motors, servos, and it has USB connections. So along with this, you can connect a second Rev Expansion Hub, which allows you for more potential and capabilities. So this recently they came out with a control hub, which is more efficient and replaces the driver control phone, and it actually has wireless connection, which is a great perk. Secondly, there's a driver hub, which is a replacement for the driver station, which is a phone. And as you can see in the image, it has a really clean and efficient layout where you can start and stop your code, see the current configuration file, and just like the phone, see the battery voltage. The driver hub and the control hub can each be swapped out with its corresponding phone. However, for optimal performance, we encourage that you use the driver and control hub. So there's multiple reasons why the driver hub has more perks as compared to the phones. One is connection issues. So recently in the past, we would have to connect USB hubs to our phones so we could connect our controllers. However, this driver hub has 3 integrated ports where you can just directly connect your controllers into it, which causes less cables to be used and better connection. So you'll be needing to make sure have your driver hub updated because Rev comes out with updates every so often, and you need to make sure that it's up to date. So, yep, that's it.
Okay, hi guys, my name is Rohan. I'm going to be talking to you about motors and servos. So the first thing is motors. So motors are the primary form of continuous movement on your robot. So these are going to control things that the most basic common things that you're going to control on your robot. So for example, your wheels or an intake or outtake, linear side, stuff like that. There's different speeds and torques for the motors for whatever variance need you have. So the minimum that we have is about 43 RPM, which is very, very high torque since torque and speed are inversely proportional. And then maximum is about 6,000 RPM. This is very, very fast. This could be used, for example, last year during Ultimate Goal to shoot a ring. That would be a good speed for that kind of mechanism. And then the average motor that you're going to use for like drivetrain intake, stuff like that is around 300 to 400 RPM. So it's a moderation of both torque and speed. You can have on your robot for FTC, you can have a maximum 8 in total. And some common examples of types of motors, those are Tetrix, Torquedo, Go Build a Yellow Jacket. Those are the ones that we personally as a team have used the most, that we like the most. And then also there's the Rev HD Hex motors. So, and like I said, they're good for things like drivetrains, intakes, linear slide, and yeah, just the most basic movement that continues to rotate over and over. Now, the other type of movement that you'll have on your robot is a servo. So servos are are more of like a position-based mechanism. So it's best for like a switch or an on and off type of thing. So like I said, it's based on position, so it has limited motion. It can only rotate about most of them are about 180 to 360 degrees total of motion. But the way you control its motion is through setting its position rather than setting a power like you would for the motors. And then you can use a servo horn to add attachments. Whatever the servo is actually moving, you would screw that into the servo horn. And then some common uses, for example, securing a grip. If you're using a claw mechanism, then a servo could be used to actually clamp onto the object, or if you are opening or locking something. So for example, this year, if you were using it to drop your freight onto the shipping hub, you could use it to actually like dislodge the object or push it off of your robot. The advantages over using those over a motor, they're smaller, much simpler and easier to use, but the disadvantages are do tend to be weaker and slower. And then of course, they also have limited motion.
All right, so the chassis of the robot is like the heart and the soul of it, which is the drivetrain. Now, the purpose of like the drivetrain is to move your robot around the field and facilitate movement. That's why it's really, really important that like you have a really good drivetrain, because that can affect all aspects of your robot. And if the drivetrain doesn't work, the rest of the robot won't work either. Now, there's a bunch of different drivetrains in FTC. However, the one we would recommend most is the GoBuilda Mechanism chassis. Now, Rohan's going to get into this a little later about what mechanism wheels are, but the GoBuilda Strafer chassis is pretty much the gold standard for teams wanting all-around design. Now, this particular chassis is really interesting because it comes with motors that actually fit under the channels rather than just plug it into the wheel. And they're also really interesting because with a mechanism wheel chassis, instead of just moving left, right, backward, forward and backward, and then having to turn to move left and right, this is actually able to strafe because of its wheel slant design. You're able to code it so where the wheels can actually just move directly left and directly right, which is actually really, really cool. So this comes with 4 mechanism wheels, which Rohan's going to talk about later, but this is probably one of the best chassis you can get for your money.
Hello, my name is Vidit Mehta. So I'll be talking about transmission of power. So for different rotational components, we can like we use motors, right? So with motors, we can also use different things such as chains, belts, gears. So the first type is called a direct drive, and this is when the motor is directly connected to the motion component. So for example, on the bottom right, the motors are directly connected to the wheels, meaning it's called a direct drive. Usually direct drive is, they're very unstable. They're usually not the best viable option because the motors are under a lot of stress of the whole robot. So sometimes the gearboxes can break. The next type is gears. So the motor is connected through a system of gears to transmit power. So the middle and the bottom, that's called a gear drivetrain. And you don't just need to use a gear for drivetrain. You can also use it for like different mechanisms that may require some gearing up or gearing down. And some of the problems with a gearing mechanism is sometimes the gears may grind if they're not spaced properly, and that may cause some mechanical failures. The most reliable option, in my opinion, is the chain and belt drive. So that's when we're using a system of chain links or like a timing belt. And that's used to transmit power to different directions of your robot. So that's the bottom left picture. And we would recommend the belt drivetrain or chain drivetrain because it's the most reliable and the most teams use it. And then finally, the bevel gears. The bevel gears are a system that is used in the GoBuilda Strafer chassis, as Kavin talked about earlier. And that helps transmit power in the 90 degree. So for example, in the top right corner, if we move one of the gears in a counterclockwise direction, the other gear, which is perpendicular to it, will also move in the opposite direction. So that's what a bevel gear is called.
Okay, so the like Kaveen was saying, one of the best features of the Strafer chassis are the mechanism wheels. So mechanism wheels are pretty much wheels that allow you to move in all four directions of motion. So with ordinary wheels, you're only able to move front and back and then rotate or turn. But with mechanism wheels, you're also allowed to strafe. And what strafing is moving pretty much left and right. So this allows you a ton more maneuverability. The way the mechanism rollers work is that they're all positioned at 45-degree angles to the actual wheel. So the roller would be angled like this, and then the wheel is actually facing this way. So there's a bunch of rollers all at a 45-degree angle. And then when you turn the wheels in a certain combination of directions, so for example, when you turn the front right wheel backwards, and the back left wheel backwards, and then the other two wheels forward, that'll make the whole robot go to the right. So when you turn it in certain combinations like that, it allows the robot to move in any direction. So again, you can use that chart on the right to for programming tips to see what motors you need to set to what powers in order to move the robot in a certain direction.
Okay, so now I'll be talking about rotational motion. So when we're having a system of different axles and gears and stuff like that, we want to minimize as much friction as possible to make the axle as smooth as possible. So we have two options. So the most popular option is the bushing. And this is famous in Rev and Tetrix building systems. And bushings are a simple way to reduce friction to some degree. They're just like some bronze component you can see on the bottom left, which helps keep the axle in play and lets it move without friction to some degree. And then the better type of method to reduce friction is called the ball bearing system, like a bearing. And this is very famous in GoBuilder building systems. As a matter of fact, GoBuilder is based on a ball bearing system. So these bearings are very efficient in reducing as much friction as possible. And they also have a thin and sleek design. So for a ball bearing is like about 4 or 5 millimeters, while like a bronze bushing is like 10 or 15. So it's very thin and sleek. And then it's also recommended for high load and high friction situations.
So now we're going to get into more of the freight frenzy specific mechanisms for which you're probably going to be using this year. Every year with every new game, there are some certain components or aspects of the robot that are more efficient or we use more often than others. So we're going to go into more detail about that. So this is our team's prototype robot we made over the past few weeks. Now we're going to go more into depth over each particular component in the robot, because it seems kind of complicated now. But the basic general logistics of how it works is you have a block or a ball come through the intake mechanism, which is attached to some surgical tubing. Now that spin brings the ball or cube into this little chamber here. Now attached to this chamber, we have this thing called a linear slide, which I think we're going to go into much more depth later out. But a linear slide, in essence, allows you to take elements of the game and move them upward, and it translates it to vertical motion. So I think we're going to get into more details about the more specifics of it. So whoever's doing this one can go.
Right. So specific to this game, one of the major challenges on this year's playing field is a large barrier that separates the freight and the shared shipping hub aside from the remainder of the field. So the main problem and the main question that a lot of teams are facing is whether to go above or towards the side. Well, both options are viable, except if you decide to go on the side, you'll have to decrease the width of your robot a lot to make sure it can pass through. So for the teams that decide to go over the barrier, there's one way that we recommend that in the image we implemented. So we decided to raise our chassis completely above the ground. So it can get stuck in the middle of the barrier. And two, when we drive over as you saw in our prototype robot, a lot of our mechanisms go pretty high. And if there's a lot of shaking, then it could risk any of our mechanisms to break. So since we have this gap between the between the barrier, we can easily get across and score freight into the shipping hub. So for wheels, the three most common wheels are omni wheels, traction wheels, and mechanism wheels. And as stated previously, we think that the most efficient kind of wheels are the mechanism wheels because, as stated, we think that its movement is the most important aspect of FTC. And with these mechanism wheels, we can easily move and stray from left to right.
Okay, so as Vitter just touched on previously right now, there's few different types of wheels that we can use, some of them being omni wheels and mechanism wheels, and then others being traction wheels. So those are categorized in two different sections. One of them which is called holonomic, and then the other one which is called non-holonomic. The holonomic drivetrains will allow us to make precise maneuvers on all 8 directions at the cost of traction. So example of this would be mechanism and then an omni wheel X drive. These usually these holonomic drivetrains are very precise. They turn very fast, and they're also like very fast in tangential velocity. But usually, if a robot pushes the robot, the robot that gets pushed will usually move around a lot. So it's a very fast, but it sacrifices traction. And then the other type of drivetrain is called the non-holonomic drivetrain. So that includes a 4-wheel drive, a 6-wheel drive, and then that's like, for example, that's the bottom left and the bottom right. Those two are called non-holonomic because they cannot go left and right. So that's why it's called non-holonomic. These robots, usually if built correctly, they have a lot of traction. They're and if they're built very well, they can actually have a higher speed than a holonomic drivetrain. But obviously, this is at a cost of maneuverability. So each of these drivetrains have different benefits and disadvantages. So for example, in Freight Frenzy, both of these types of drivetrains are viable. Mechanism, you would have to make some sort of adjustments because mechanisms don't have enough traction to get over the pipes. So we may need to raise the barrier or something, so make sure that the wheels hit the pipes first, have a great contact point. But and you also have to make sure that the robot doesn't get stuck in between the 2 or 3 inch gap in between the 2 pipes. However, for a 6-wheel drive, since there's a lot of traction and there will be like 6 wheels, one in the front, one in the middle, and one in the back, that will allow for a very like reliable drivetrain that won't get stuck inside the barrier. So as a team, you would have to make sure to know which drivetrain that you want.
Hi, my name is Devin, and as previously mentioned by Vidur, there are barriers around the arena in Freight Frenzy, and to get over this, there is a method of raising your robot, which is called the tile riser, and it's basically cuts underneath the chassis that allow the robot to traverse over the barriers easily, and this is really useful in both controller and autonomous modes because it saves time and it reduces the risk of the robot getting stuck on the barrier, which could eliminate your robot from the competition fully. So this is shown in this the image that I've provided in the bottom right, and it basically raises the robot. So and it could be built with a variety of wheels, including mechanism, traction, and omni wheels. And it's usually it's only built with a 4-wheel drive configuration. So if you're planning using 6 wheels, you should use different methods. This is used to traverse barriers, and it's helped to use multiple cycles fast and leaves gaps in the scenario in which your partner may need to use the area in the 13-inch section where you don't need to traverse the barrier.
Kameen, can you go back to the previous slide? I'll like.
Oh, yeah, sure.
Sorry. Yeah, so this is one of the kits that Andy Mark sells, the drivetrain. So I just put a link to the chat in the chat. I just put a link in the chat. So this this drivetrain is built for the freight frenzy season, and it's built with the mindset that it's not going to get stuck in the barrier. So for any new team that may need a drivetrain to begin with, this is a very good idea.
All right. So I'm going to go into more detail about the 13 versus 18-inch drivetrain. Now, for those that aren't fully familiar with the game, in order to get to the freight, there are two options you have. You can either, one, go over the two pipes, which we've discussed, which are just pipes that are elevated off the ground. But there's also a 13-inch gap on the side of those pipes for a robot that can get through. Now, the huge question teams have to ask this year is, which should we choose, a 13-inch drivetrain or an 18-inch drivetrain? Now, an 18-inch drivetrain has the benefits, a 13-inch drivetrain is very useful because teams you don't have to deal with all this raising your chassis and making all these adjustments and tilerizing when you can just go around it. And it's really, really helpful because it really minimizes the risk of getting stuck. And also really huge benefit is that it allows you to do autonomous cycles much more consistently because you don't have this added component of trying to record your robot's movements when you're going over these pipes, which can be really, really unpredictable. So this 13-inch robot, it definitely has its benefits because you really just don't have the added obstacles. However, the huge disadvantage and the advantage of the 18-inch robot is that you're able to travel, you're able to travel less distance to the shipping hub because the shipping hub is closer to the pipes than it is the gap. But additionally, it's that you're able to fit more components just on your robot. Because the 18-inch, although it seems pretty big for rookie teams, an 18-inch really, really isn't that big. And especially when you're trying to fit all your components on your robot, it can get pretty difficult. So by shrinking yourself down even more, it makes it really, really difficult to fit everything you want to on the robot and all components you want to on the robot, which makes space management really, really key. So yeah. So at the end of the day, it really just comes down to team's personal preference and your game strategy. However, if you are planning to go around or you try to get more autonomous cycle times and you're working around that, then 13-inch drive should be better. But if your team feels that you need maybe more components or you're not going to be able to fit everything on, that's when you'd prefer an 18-inch drivetrain.
I mean, can you go back to the previous slide? Just that.
Sorry.
Yeah. So one more thing, an advantage to the 13-inch drivetrain is that if the alliance, for example, will get stuck, which is bound to happen, if your alliance gets stuck in between the poles, you won't have any access point to get into the minerals, the freight, which can be which could affect your score. So 13-inch could help with that, but packaging all the motors and different components would be a very tough drive. So
yeah, just to elaborate off of what Vidi was saying, a huge part of FTC is having a teammate. However, in the event, which it's going to happen to you, a teammate is either going to get stuck, the robot's going to turn off. You have to have ways to be self-sufficient so you're not reliant on other people. You're not relying on your teammates too much, because if you are, that means if your teammate kind of goes down, then that might affect you as well. So just being able to have both options. And again, another thing about the 13 inches is that you're still able to go over the pipes, worst case scenario, if you make the adjustments you need, which we've done in our prototype robot. So if in case someone gets stuck in that area or it's very hard to get over that, then you're still able to get over both. So that's another advantage, that with 13 inch, you have a choice. So yeah, surgical tubing.
So the next part of the freight frenzy next consideration is about intake. So how are we going to get the freight onto our robot in order to manipulate it and actually get it onto the shipping hub? So one very, very useful tool for intakes in general is surgical tubing. It's a really like flexible, grippy material, but it's also comes in different variations, some of which are very tough as well. So you can wrap, you can see in the picture on the right, you can wrap the surgical tubing around some sort of axle or pipe to and spin it relatively quickly around 300 or 400 RPM. That'll make it spin really fast. And then as soon as the mineral comes in contact with the surgical tubing, since it's so grippy, it'll automatically pretty much just like suck the mineral into whatever transfer mechanism you have to get that onto your robot. So we've actually started prototyping with this already with our prototype robot. we have some surgical tubing that's there for the intake that allows it to, that pretty much just propels it into the transfer mechanism and allows it to move on in its process of getting into the shipping part. So, and also one more thing that everyone needs to consider for this year, I just wanted to bring up, is that in case you didn't know, this year there's a there's a possession limit of only one piece of freight. So you can only hold one piece of freight at a time, is what that means. So a disadvantage to having a robot like the one on the right is that you could easily suck in 2 or 3 at a time and then get a penalty for violating the possession limit rule. So when you're designing your intake, you definitely need to take that into consideration and make sure that it's very, very difficult for more than one piece of freight to get into your robot at a time. That way you can kind of prevent errors and make sure you don't get any accidental penalties.
Also, this stuff is like amazing for intakes just because it's so grippy, and although it seems pretty flimsy at first, like just because you're spinning at such high speeds, this is probably, if not the most efficient way, like it's one of the most efficient, if not the most efficient way to get stuff into your robot.
There are yeah, just go. I'll talk about it.
Okay, yeah, so the next method of intake are gecko wheels. They're silicone rubber wheels that are spun at really high rates, really high rotation, and are used to basically pull in freight in this case. And the wheels are able to slightly compress and conform around objects. So like even if it's like slightly too small of an area for an object to fit through, they might be able to like conform. So that's good. This wheel is also good in the case that it's not too hard to only take in one object, because you can kind of in comparison to surgical tubing, you can decide how far the wheels are apart, and in order to only take in one object at a time. And they're really reliable because they grip well onto different objects, and they're a really viable method of intake.
Actually, if you have an example of a gecko wheel, you can grab real quick. Probably show them that.
Yeah, I'll grab it. Cool. And then to add on, there's this other type of wheel. Yeah, there's this other type of wheel called an entraption star that's also sold by Andymar. It's currently out of stock. But these wheels, they're like they're also really, really good for taking in minerals. They came out in Ultimate Gold, but now for Freight Frenzy, they're better than ever. So, and it's very popular because obviously it's estimating to be back in January 2022, so it's out of stock already. But you could also, if you have access to a 3D printer, you could 3D print these entraption stars and see how they work for your robot.
So another method of intake is a claw. This is really good in Freight Frenzy for the reason that you can easily control how many objects you intake. And since there's, as Rohan previously mentioned, you can only intake one object at a time, it is really easy to regulate that with a claw. It's basically just a claw that grips onto objects and intakes them. The only disadvantage of this is that it's somewhat slow if you aren't able to make the claw reliable enough. And although it is easy to regulate how many objects you intake at once, and it is precise, it is rather slow when you're trying to cycle your robot and get as many objects as possible as fast as you can.
Yeah, a main drawback from the claw is that the amount of driver precision you need to line up each and every object is really, really difficult, because you have to have like that very precise measurements. But additionally, in this year's game, because the elements or the freight is all packed into one tiny square, a claw mechanism may not be the most ideal because the claw can get stuck on other items and it won't be able to converge just on one.
Okay, so coming back to Devin's previous talk about the gecko wheel, you could just take a look at my screen. So this is a prototype that we made. So it's just basically on some Go Build a channels with some bearings, as we talked about earlier. And then we have this cut up gecko wheel. So we cut up, so then they have these tiny different sprockets around them. And then when this spins at high speeds, it'll be able to suck in the blocks and the spheres, the blocks and spheres.
All right, so pretty much the gold standard of vertical motion in Freight Frenzy in any game that you're going to need to move stuff to higher place are linear slides. Now, this stuff is absolutely awesome. You pretty much can't live without it. It is amazing, and I'm going to go into more detail. So linear slides provide excellent one-dimensional movement, and it gives the robot the capability to reach different heights and lengths. Rohan, you can continue.
Yeah, so linear slides, pretty much they're just different levels they're composed of different levels, and each level pretty much slides over the other. That's why it's called a linear slide. And then so it has the ability of being very, very compact, because when they're all stacked on top of each other, the mechanism's short, but it's useful in cases where you need to extend some sort of mechanism outside of your robot, because then you can slide out all of those different levels that you have, and eventually you'll have, if you have, for example, 4 levels, then you can get quadruple the length of that same channel and reach somewhere else. So yeah, you can it's ideal, for example, this year when you need to put an item on the shared shipping hub. The highest shipping hub is like 12 inches off the ground, right? So your robot itself may not be 12 inches tall, or may not have its transfer mechanism might not be 12 inches tall to actually put the freight onto the shipping hub. So instead, you'll need to use a linear slide, and that linear slide will allow you to extend your transfer mechanism up to whatever height you need to, and actually deposit onto the shipping hub. So some good companies, as examples for linear slides, GoBuilda, it's coming out with Viper slides sometime this month, I believe, specifically for Freight Frenzy. And then Servo City comes out with a cascading rail kit. That's what we've used in our prototype robot. It may not be good for a final design, but it's definitely good if for an initial design if you want to test. Okay, and so then the other thing I wanted to touch on is that linear slides don't just have to go vertically. So something else you can do is you can have a slide that moves in an angled direction. So for example, this year, we, for our prototype robot, like I was saying, we have a linear slide that actually just goes at an angle and moves outward. And then that angle is adjustable by another motor. So what that allows us to do is, from no matter what distance we are from the shipping hub, that we can change the angle of our linear slide mechanism and then extend it out all the way. And that'll allow us to deposit pretty much anywhere else on the field onto the shipping hub. So there's a lot of things you can play with for linear slide mechanisms. It's just whatever you can think of. You can even have just like a completely horizontal linear slide if you want to have a better intake that goes all the way outwards, instead of having to go completely into the mess of freight to pick up the piece of freight. So it's just whatever you want to do with it. It has a lot of possibilities.
Yeah, so it's not mentioned on here, but currently we just have the GoBuilda linear slide, and then also the Servo City. But there's also this other company called Long Robotics, and they sell ball bearing slides, which are very, very smooth. And you will require some 3D printed inserts, which is a bit more complicated, but it's a very good slide. So I'm currently making like a document with all the different linear slide links for like 4 different companies. So feel free to look.
Right.
Okay, so now I'm already talking about some miscellaneous outtakes. So what I mean by miscellaneous, I mean out of the like custom, like basically out of the linear slide system that we have. So first idea is the rack and pinion. So this is an alternative to linear slides, and it has a gear that slides past the rack, which moves the channel up and down. Usually this is just like an alternative to a linear slide. There's no huge advantage to this. I wouldn't recommend it. It's a very simple design which has many flaws. The next idea is a conveyor belt design. So like what I mean by conveyor belt, I mean like taking a mineral and then have a conveyor belt that moves it upwards all the way to the top or wherever you want to score. And so that's one of the ideas. That's a complicated idea for a simple challenge, but it could work. And then finally, I think it was Kaveen that talked about earlier, the arm. So we can just like grab the mineral and then rotate it all the way around to drop the freight into the shipping hub. So with this idea, if it's very well designed, it can have great advantages and it can possibly outscore the linear slide. But and like an idea you can see on the bottom right is a very, very simple design of a claw that uses a servo, which can grab both spheres and cubes, but it just may be a bit harder.
So last but not least, at least I'm going to be talking about compliant wheels. So compliant wheels are just small grippy wheels that can be used diversely on your robot. And as you can see in the image, they're very squishy and sponge-like, so they would not work for drivetrain. However, they're super useful for certain mechanisms on your robot. So these compliant wheels, they come in multiple different sizes, and you can just buy the correct ones that you feel suit the best on your robot for different mechanisms. So I'm going to be talking most specifically about the carousel. So as y'all may know, one of the ways you can score points in this year's challenge is by spinning a carousel on the corner of the field that spins the duck that falls, which ideally falls into the playing field. So we recommend one easy way to make a mechanism that is super efficient is just to have a vertical channel with a motor and just attach the compliant wheels on top of it so it can just spin and slowly rotate the carousel. So this these motors can are attached to the rev expansion hub, and I forgot to mention earlier, but on your rev expansion hubs and on your control and on your driver hub, you need to make a configuration file. So this configuration file, basically all it does is it just states what kind of motor or servo you're attaching and the name of it and which dedicated port you chose to attach it to on the rev expansion hub. So there are different types of motors, and each motor has a different amount of torque and speed inversely.
All right, thank you guys for listening. That's going to conclude the presentation. At this point, we can take any questions you guys may have. So feel free to unmute and just ask. Or you can
Or you can add to the chat. Just
yes, we can share the slideshow with you all. If you'd like to put your email in the chat, I can share you guys with that.
Or I can just download the presentation and we can send it.
You know what, video, I'm just gonna make it a shareable link and then put it in the chat.
that works too. Does anybody have any questions at all? Oh, okay, we have one. How do you know what materials is FTC approved? If you check the game manual part 1 or part 2, it'll have the list in there that tell you what's allowed, but most things are pretty much allowed besides blades, fire, or anything that can harm or anything with sharp edges. It's not a lot that's actually illegal besides hardware wise, electrical hardware. So as long as you're using the correct up-to-date, which is the expansion hub or the control hub or the driver hub, you're pretty much good. There's a huge selection of motors, there's a huge selection of wheels. Another question, do we know when the meet schedule is coming out? Not yet. We'll probably let y'all know that, if not by next week, the week after. Brian said he's making a list to send out to the teams to make it easier and to inform everybody at once instead of just letting random people know at random times. So we're getting that together.
In the chat, a PDF of FTC's approved parts.
And we also put the link to the presentation in case you would like to do that.
Are there any more questions? What would y'all consider to be the most time efficient attachments?
So when it comes to like attachments wise, yeah, I agree. A huge part of FTC is just being efficient with movement. So one is, especially with movement, is it's a lot easier to move like an arm, like a linear slide, than it is to like move your whole robot. So we'd recommend like probably like what we're using for our prototype robot is mechanism wheels. So we're able to drive in all directions, but we have it raised up with the tile riser method. So just using that to get over, and then also we definitely recommend if y'all can make linear slides work with something attached to that. That is a huge advantage compared to like an arm or any other mechanism. Linear slides are pretty much the best method. Like all of the elite teams out there, that's what they're using. So linear slides are easily the best way to get a mineral up and down. But when it comes to intakes, is that I would personally recommend surgical tubing, but like having a mechanism that's kind of narrower to account for that one mineral or one freight allowance. But yeah, I'd say surgical tubing for intake and a linear slide, probably the two main things you're going to want to incorporate.
And then one of the easiest things, in my opinion, to add is just that carousel mechanism. So all it is that is a channel attached to a compliant wheel with the motor. And that allows you to get, I think it's like 60 points in endgame, and then even more in autonomous if you can program your robot to do that. So that's just like probably the most simple robot, a simple mechanism on your robot, and yet it allows you to get so many points. So definitely for all of you guys, I would recommend for the first competition, definitely at least have that mechanism, just because it's so it's very simple to design, and it can score you a lot of points. So
which mechanism are you talking
about? The carousel mechanism.
The carousel mechanism. So it's just a channel and a wheel. I can go back to the presentation and actually share that.
Yeah, so it was what Vidar talked about at the end with the compliant wheels. Just adding a compliant wheel with a channel. Yeah, I'll let Vidar talk more.
Yeah, I was just gonna add on that maybe in the prototype picture that we have on the slides, I might have an angle of, or if you want to show the mechanism that we just prototyped.
Yeah, I don't.
Yeah, I'll find. I'm finding. I'm finding a duck mechanism right now.
Okay.
All right. Is it okay if I unmute to ask this question?
Yeah, sure. Go ahead.
All right. With linear slides, I know they have that vertical movement, but for this competition, I had a feeling that you'd be in a position where if you could have a linear slide that could rotate as well like that, that would also be advantages. But I'm really not sure. Like, are there any mechanisms that could allow a linear slide to like move on its axis like that?
Yeah, that's actually what we did in our prototype robot. So the way we have it is a linear slide.
You can show the picture. I mean, the picture of our robot.
Oh yeah, I can. Here, let me share. Let me share that real quick. Right here.
That's a good question, though.
That's a great question. So this is what our robot. Now, if you can see here, we have our linear slide mounted straight up, but the reason is like a linear slide just goes in one direction, but it really is up to the way you mount it. So like, as you can see right here, we have it mounted the channel here. Now this channel, you can just screw it in directly to something, and that's the fixed angle it'll be at. But the way we did it is we have a motor right here, and we attached it to this gear configuration. And this gear configuration pretty much shifts the angle of the power so that turns this way, while the motor configuration is still there. And we actually attach this gear configuration to the channel. So the channel that the slides are mounted on is actually able to move like that. And that's actually really helpful because, again, you can change the angle at which you're going to use the linear slide. So that's the way we did that. But there's a bunch of other, you can just mount it directly to the channel, or there's a bunch of other configurations of how you can do that.
Yeah, so to answer your question about how to do it, pretty much just put an axle onto your robot that runs across the robot, then attach that axle with the channel to your linear slide itself. And then when you rotate the axle, the entire linear slide will rotate with it as well.
And someone asked a question about there are different variations of surgical tubing. Can you share one that you recommend? That'd be you.
Yeah, I'll find it right now.
Yeah, so Pretty much most surgical tubing will work. We just went to like Lowe's and grabbed some off the shelf, but when it comes to surgical tubing, it's not that different. It really just comes down to thickness and how thick you want it. It's not really like on flexibility, but it's more like there's thin pieces you can buy or thick pieces. It really is just down to personal preference, but yeah, just your thick, like your regular size, everyday hardware store surgical tubing should be sufficient enough. Just make sure it's the rubber part.
Yeah, so this year actually when we were prototyping our intake, we had one substance that was like almost like a glow stick, the kind of thing that you crack. It was like that. So it was still, I think, technically considered surgical tubing, but it was really, really stiff and not as good. So then what we did was we actually have that that material, that substance, and then we put a grippier piece of surgical tubing on top of that. Like we slid it into another piece of surgical tubing that was really, really grippy. So now we can kind of have the best of both worlds. So it's both very, very stiff, like it's tough to take a piece of freight, and then it also has that grip strength with the other piece of surgical tubing. So it's really just up to your personal preference. But I think Vidit has the link for the specific ones that we bought. So
These are great questions so far. Are there any more questions?
I just brought down some surgical tubing from the room upstairs, so. Let me
You might have to turn off your background.
All right, so these are the two types of surgical tubing we're using. So this one you can see is a bit softer. This is like the normal type of surgical tubing you would find. And then this one is a bit harder. So like it's really hard to move comparatively. As Roland said, it's like a glow stick basically.
It's kind of like a plastic, almost like IV tube.
Yeah. So then what we did is we just stuck this through the big surgical tubing. And then so now we have like something grippy. And then also it's somewhat flexible. So then it can easily grab onto the mineral, the freight, sorry.
Yeah. And for you, Reed, someone asked where will the session be recorded so you can share with the team.
Yes, it is being recorded currently. We made a new YouTube channel to add it on a new FTC East Texas region YouTube channel to then add these on. But we want to also create a new East Texas region website, so then we can also put it there, so that way there's also more information for y'all to get to. We're just currently working on that. And we plan to, once we get this downloaded and figure out a place to put this, we will send out an email to all the teams, so that way they have a place to go look for it and to go watch it, and hopefully within the next week or two. Getting my hopes up a little bit, but that's the plan.
Okay. If there's no other questions, I'm going to be sending in like an example cycle of how all the mechanisms work for our robot. So
No, there's no Twitter yet.
So I'll be showing how the intake.
Oh, sorry.
So we'll have like an intake running, and then the block will go into the. The block will go into the transfer site, and then it'll like we're angling it, and then it'll extend out. So if I'm trying to send it to myself so I can share it.
Okay, we got like
Wait,
5
Screen
minutes.
share it? I can just screen share it.
That's a good point.
Right, if you have it on your computer, you screen share it.
While he's doing that real quick, we're getting real close to the end. We got like 5 minutes till 7. Yeah. There's any other final questions? Throw them in the chat, ask them, don't be afraid. We might go a little bit over, but I don't want to hold y'all for too long. I thank everybody for coming. I gotta thank Robo Sapiens for actually being the presenters today, being our first presenters. Can I get this recording for my team meet on Thursday? I'll try and get it to you, Spoonie. And our meeting person this year, that's a Brian question. So I can't really answer that. I want to. The
My
host,
understanding is that it's based on the league and what they decide.
yes. So if the league decides to do in person, they have to do in person for the rest of the season until championship. But if the league decides to do remote play, then they have to do remote play the entire time. And we're gonna, like Brian said last year, we're gonna have one league that's made specifically just for remote, in case the school changes their preferences, saying that they don't want no more field trips or anything. But we're kind of going with getting new information as we go. So we're just trying to get everything set up for y'all and make it smooth for y'all, so where y'all don't have to go through anything crazy and get frustrated either, because we don't want y'all frustrated.
Reed, could you make me a video so I can show the video? So, because Toba wants to know how it's angling, so I'll show how they think.
And boom, you are.
Okay, so this is this is like an example cycle of how everything would work. So I'll just start. So we have the intake, it goes in, and then like you can see, I don't know if it's possible, but you can see how it angles down, and you see how the whole axle moves down, right? So that's how it's angling. I'll run that again.
That was real cool. It's almost like a seesaw, like a teeter-totter. Okay. Yeah.
All right, thank you. I see you now.
Awesome. Thank you guys so much for coming and watching us.
Okay, well, if there's no other final questions, thank y'all audience for coming to do this, and see y'all next week.
Thank you guys.
Thank you.
Bye, thank you.